All right, so what we're talking about with polynomials is extrema. And extrema are turning points where the graph, and I have a little terrible sketch right here, where the graph goes from going up to going down. Or, as is the case down here, from going down to going up. So turning points are where we switch from either decreasing to increasing, or from increasing to decreasing. It doesn't matter. And what we get when we have these is basically two cases. We could have what looks like a hill, which is going to be a max, or we have a valley, which is going to be a minimum. So right here, we have a max. Right here, we have a min. And right here, we have a max. So we could have lots of these. But there are going to be, of these two different kinds, mins and maxes, we could have relative extrema, or relative turning points, or absolute minimum or turning points. So a relative means just in the area surrounding. So if we take a look at my picture right here, I do have two relative extrema. So the first relative extrema is right here. This is a relative max, meaning it's still an extrema. We do switch from going up to going down, but it's not the absolute largest that this graph gets, because over here our graph is bigger. If we take a look at right here, we also have a relative. This is a relative min. And it's a relative minimum because it's not the absolute smallest the graph gets. In fact, we're smaller over here and over here because the graph dips down. But it's still relatively smaller than the area around it. And this one, though, is a absolute max, meaning that it's the absolute highest that the graph ever gets. And it's actually possible that our graph is neither of these. We could have a graph that or not neither of them, but a graph that has no absolutes. So if we take a look at this sketch that I'm going to do right here, this is the case for most odd functions. I can't even think of an odd function that this isn't the case for. But here we have a relative maximum, and right here we would have a relative minimum. Neither of these are absolute. Why? Because our graph actually does get smaller over here, and our graph actually gets bigger right here. So what we want to be able to do is actually find out, well, where are these points? And they don't come out usually very nice. And for now, we're going to figure them out using a graphing calculator. So I have a function set up here, and I'm going to pull up a graphing calculator, and I'm going to put this in. So we do need to go to graph mode. So I'll highlight graph mode, and we'll go into that. And we're just going to type this in. So x to the third plus 7x squared. Oh, need to make sure I'm out of that. All right, plus 7x squared plus 4x minus 12. We'll go ahead and do this. So we are going to hit execute, enter that graph. We'll draw it. So we're going to go ahead and draw it. And we can see it's graphed some things, but I can't actually see the maxes and mins. So I'm going to have to zoom out. So before I start zooming out, I want to make sure that my view window is good. So a good view window to start with generally is -20 for a min, 20 for a max, and the scale of 1's okay, I suppose, and -20 here, and 20 right here. So this is a good square view window. And now we'll go back and draw it and see if we're any closer. So I can see this one a little bit, so I might want to zoom out. So we hit zoom. We'll just zoom out. Nope. Zoom out is this one. And we do get a cursor asking us where do we want our center. So I just want my center at the origin. Now I can see the graph a little bit better. So now what I'm going to do is graph solve. So depending upon the calculator, we might need to do this a little bit different. So on a TI, we are going to press our second key, and then we're going to find at the top the word calc, which is going to be in blue, and then a menu is going to come up, and we're either going to select minimum or maximum. On a different calculator, such as the one I'm using right here, Casio, our steps are to do the, let's see, what were the steps? Shift and G solve. And again, we're going to then, from the menu that comes up, either select minimum or maximum. Now, we're going to have some extra steps for both of these calculators after this, but they're a little bit different. So on the TI, we're going to be asked for the left bound, the right bound, and guess. And on the Casio, we don't really have any of that question, but we are going to be asked, we're going to need to arrow to which one we want. Okay, so we hit graph solve, and I'm going to select, the first one is right here, that's maximum, so I'm going to select maximum, and we see that my cursor pops over to it, and down here is my answer, the X value and the Y value. So I'd want to write this as an ordered pair, and generally we'll just keep 2 decimal places, and if I wanted the minimum, I would hit G solve, and I would hit minimum. And then it gives me the minimum. Here is the minimum. And keep 2 decimal places. But what we're going to need to make sure that we do is on other calculators, we're going to need to do that left bound, right bound, which means I'm actually going to have to move the cursor to the left and to the right, and then hit enter on the guess. So what that looks like, because it's going to be hard to show, but my graph looks like this. When it asks for the left bound, I move my cursor. Here's my answer. I'm going to move my cursor over to the left of it, and then I'm going to press enter. And then I'm going to move my cursor to the right of it, and then I'm going to press enter. And then after I've done that, it's going to ask me for a guess. I'll move my cursor close to this, or actually anywhere in between these two. And again, I'm going to press enter. At that point, at the bottom, it'll tell me the X and Y coordinate. As I'm doing this left bound, right bound, and guess, I need to make sure that the guess is sandwiched between left and right bound, and I also need to make sure that neither of these bounds cross over to the other maximum or minimum at all, because then I might pick up something and it not work out. Okay, so we got our answers for that one. Here's another one. So we go ahead and we put this in. So I'll delete this graph, and we'll type this one in. And while I'm typing it in, just important to note that we can use this same process if we wanted to find the zeros or the roots of the function, the left bound, right bound guess. We can get actual one, the actual exact roots. Now, for real roots, the rational ones, sometimes we can just look at it and know what they are, but if they're irrational, then we can't. All right, we'll go ahead and draw that. Now we can see I've zoomed out, so I can't really see what's going on here, so I can use my zoom, but this time I'm going to do a box zoom. Just so there's a variety of ways that we can see what's going on here. And I'll hit execute, and I will draw a box around this so we can see it really good. So it's going to set my view window to show just that. And I get this nice curve so I can see these. And now I'm going to do yet again G self, and I want my, so if I wanted the roots where it crosses, I would hit root here instead. But I don't want those. I'm going to get, this is a minimum, and in fact this is an absolute minimum, but the calculator doesn't make a distinction. So there, this is my minimum, and then gsolve. The next one's a maximum. This one's a relative max, so maximum. I get my maximum. And just to show, I could have gotten both the minimums right away, so I'll just show that. So here's the minimum. Press arrow, and now I get my other minimum. So using the arrow keys, I can switch between both the minimums, or if there are more, it's pretty convenient. All right, if there were any other examples that you wanted, I won't do this particular example, but here are a few that you could try on your own.